Have you ever wondered what it really takes to build the tech of tomorrow? The stuff that's changing our world? Well, it's not magic. It's actually a meticulously designed plan. So today, we're going to deconstruct the blueprint for a modern engineer, and we'll turn what looks like a simple university curriculum into a pretty exciting journey of creation.
So that's the big question, right? What does it actually take to build the future? We're going to break down the structured path that takes a student all the way from the absolute fundamentals to the cutting edge of technology. And yes, that includes the very AI that is completely reshaping our world as we speak.
And just so you know, we're not just making this up. Our entire breakdown is based on a real-world program, the Bachelor of Engineering in Computer Science and Engineering curriculum from Anna University. This is a program designed from the ground up to forge the next generation of engineers. Every great structure, whether it's a massive skyscraper or an incredibly complex piece of software, it all starts with a blueprint. And for an engineer, that blueprint is defined first and foremost by its end goals, a set of core professional abilities they absolutely have to have.
So these are what the curriculum actually calls program outcomes. Think of them as the core abilities that the entire four-year journey is designed to build. This is a huge recognition that a great engineer isn't just someone who can code. Nope, they're a problem solver, a creative designer, a great collaborator, and, this is key, a lifelong learner who can adapt to whatever new tech comes their way.
All right, so where does it all begin? Well, the journey starts by laying a solid, non-negotiable foundation. The first couple of semesters are all about forging that core in science and getting a handle on the fundamental logic of programming.
That first year really hones in on two fundamental languages. First, the mathematics of change through applied calculus, and second, the pure logic of problem solving with programming languages like C. This stuff is the absolute bedrock that all advanced technology is built on top of. Then, in the second semester, something crucial happens. There's a shift to object-oriented programming. Now, this isn't just another coding language. It's a totally different way of thinking. It teaches you how to build really complex software in a modular, manageable way. It's kind of like using digital Legos to construct these incredibly intricate models. Okay, so with that strong foundation in place, what's next? Well, the next phase is all about acquiring the powerful, versatile tools that every single tech professional needs to master. This is where you really build out your toolkit.
And notice the super logical sequence here. First, you learn to organize information efficiently with data structures. Then, you use algorithms to create step-by-step solutions for problems. After that, you learn how to manage massive, and I mean massive, amounts of data. And finally, you figure out how it all connects across the globe through computer networks. It's a progressive journey to mastering digital information at a global scale. And that's the key thing to remember here. These aren't just abstract courses you have to pass. They are the literal tools used to build, connect, and organize our digital world. Seriously, think of these skills as the essential toolkit for any architect of our technological future.
So once you've mastered that core toolkit, the journey gets even more exciting. Now you get to specialize, to really focus on the incredible technologies that are shaping our world, like right now. Yeah, this is the point where you shift from being a generalist to becoming an expert. You get to dive deep into the most exciting and in-demand fields in tech today.
The curriculum basically gives you choices through these specialized streams. You can chart a course to become an expert in artificial intelligence, a master of data analytics, or maybe a pioneer in the Internet of Things, product development, or even security. You get to pick your path.
And just look at these courses. This is where the blueprint truly meets the future. We're talking large language models, deep learning, generative AI. That's the tech behind tools like ChatGPT. But it doesn't stop there. You can dive into augmented and virtual reality, you can get into blockchain, and you can even get a head start on the next revolution with quantum computing. How cool is that?
But okay, you have all this incredible knowledge. How do you actually apply it? Well, the final part of the blueprint is all about bridging that gap between academic theory and real-world hands-on industry experience.
In the final semester, students get a really important choice that pretty much defines their launch into the professional world. They can either develop a huge, comprehensive project inside the university to show off their skills, or they can take those skills directly into an industrial setting with an internship that also counts as their final project. You see, the program is systematically preparing you for this launch. It kicks off with a summer internship, it builds business acumen with courses on engineering entrepreneurship, and it all culminates in that final career-defining project or internship. It is a very deliberate bridge to your professional future.
So you see the journey, right? You go from a solid foundation to building a powerful toolkit, then you move into specializing in these cutting-edge fields, and finally, you're launching your career. This entire 4-year journey is a complete, carefully designed arc that's meant to transform a student into an industry-ready innovator.
So the blueprint is here. It's a clear, powerful path from student to creator, a guide to building the very fabric of our digital future. And that leaves us with just one question left to ask. What will you build with it?